In this video, I'll show you how to solve the ALEKS problem called deducing the ions in a polyatomic ionic compound from its empirical formula. To help you solve this problem, you're going to want to have a periodic table handy. You're also going to want to have a table of common polyatomic ions. I really like this table from Socratic.org, which you can use any table that you want. ALEKS is giving us the formulas of 4 ionic compounds, and it wants us to write the formulas of the cations and anions in each one of these compounds. Some of these compounds are going to contain polyatomic ions, and some of them are not. So the first thing that I'm going to go over with you is how to tell if the compound contains a polyatomic ion. And I'm actually going to start at the bottom of my list with this guy down here, ammonium sulfide. So in this particular ionic compound, you can see that there are parentheses included in the formula, and I love that when there are parentheses present because the parentheses are wrapping themselves around a polyatomic ion. So whenever you have the parentheses present, you know that you are looking at a polyatomic ion inside the parentheses. This makes it pretty simple for us to figure out the formula and the charge. We know that NH4 is our polyatomic ion. We just need to go to a table of polyatomic ions, find NH4 so that we can look up what its charge is. There it is, and we can see that NH4 has a positive charge, NH4+. Now in this box here, ALEKS just wants us to write the formula of the ions. It does not want us to say anything about the quantity, so we're not going to be doing anything with this 2 here. Also, you do not put parentheses around it unless it's part of an ionic compound, so you don't want to write it like this, you don't want to write it like this, you don't want to do anything with this 2. It just wants the formula of the ion. So since NH4+ is our cation, that means that this guy, sulfide, is our anion. We need to figure out what its charge is. That's part of this problem. So one of the tricks that I have for figuring out the charge on a non-polyatomic ion is to find that ion on the periodic table. A lot of the elements have predictable charges that we can predict based on their location on the periodic table. So here is sulfur. And sulfur is in an area of the periodic table where we can really easily predict its charge. Here's a little trick that I use. +1, +2, +3, skip the next column, -3, -2, -1, skip the next column. This trick is saying that all of the elements in this column, they form +1 ions. These guys form +2s. These are the +3s, -3s, -2s, -1s. These elements we just skip with this particular trick. So sulfur is in the -2 column, which means that the sulfide ion is a -2 ion. Now, let's talk a little bit about what about these guys right here, because they are going to come up in this problem. These are elements that form multiple ions, multiple different possibilities for charges, not something that we can predict based on their location on the periodic table, but we do have tricks for figuring them out as well. All right, so let's just keep moving up this. Let's do this compound next. For this one, we don't have any parentheses helping us out, tipping us off to the fact that there's a polyatomic ion. That doesn't mean that there's not a polyatomic ion. If you don't have parentheses present, then the next thing that I want you to do is count up the total number of types of atoms in the molecule, not the total quantity of atoms, but the total types. This compound has 3 different types of atoms. It has a chromium, it has a phosphorus, it has an oxygen. If you have 3 or more types of atoms, you have a polyatomic ion. The polyatomic ion stays together in the ionic compound. So the polyatomic ion is either CRP or it is PO4, one or the other. So again, let's kind of write that down. If you have 3 or more types, not quantity, but types of atoms, that means that you have a polyatomic ion somewhere, and your job is to find that polyatomic ion. The parentheses aren't helping you out. The atoms in the polyatomic ion do stay together, so maybe it's CRP, maybe it's PO4. We're going to go to this list of polyatomic ions, and we're just going to look for both possibilities. Here's a couple of polyatomic ions that involve chromium, but neither of them include the phosphorus, so we definitely don't have a polyatomic ion of CRP. That means it's got to be PO4, Let's go find it. There it is. Why are we even looking this up? Because we need to know its charge. That's part of the problem. Like, we know that the polyatomic ion is PO4, but we have to include its charge in this answer. So there's the charge on the phosphate ion, PO4 3-. And since we know that that's our anion, that means that the chromium must be our cation. So let's go check out the periodic table and see what its charge is. Here is chromium, and it is in the area of the periodic table where we cannot easily predict the charge on that particular ion. So how are we going to figure it out? Don't be tempted to try to look it up on the internet, because remember, I told you these metals form multiple different ions. So this could be a +6 ion. This could be a +3 ion. There's a lot of options. We have to figure out which one it is in this particular compound. So to help us figure out the charge on that chromium ion, we're going to try to remember that the sum of all of the charges of all of the ions in this compound has to add up to 0. And we know that the phosphate, the PO4, has a -3 charge. We figured that out by looking at it on the table. So that tells us logically that the chromium needs to have a +3 charge in order for this math to work out, in order for these ions to add up to a total charge of 0. Now, if that was kind of a stressful thing that just happened there, don't worry, we're going to practice it again with this next problem right here. So looking at this, your first job is to ask yourself, do I have a polyatomic ion present? We can see that there are a total of 3 different types of atoms in this molecule. So that means, yes, there is a polyatomic ion. It is either CuS or it is SO4. We're going to go looking on the table of polyatomic ions. It's the last one on the list right there, SO4 2-. That is our anion, SO4 2-. And that means that this guy is our cation. Let's figure out what its charge is. Let's find it on the periodic table. It is right here. There's another one that is in the area where we can't easily predict its charge. But we do know that these ions add up to a total charge of 0, and we know that the sulfate, SO4, has a charge of -2, which means that the copper in this case needs to have a charge of +2 in this particular compound. Now here's our last example. First thing that we want to do is ask ourselves, is there a polyatomic ion present? This has only 2 types of atoms or ions. It has vanadium and it has bromide. That means that there is no polyatomic ion in this guy. No polyatomic. So if you have no polyatomic ion, the convention is that the first element in the formula is the cation and the second element in the formula is the anion. This 3, because this is not bromide here, is not a polyatomic ion. This 3 is indicating the quantity of the bromide ions. It is not something that you include in the formula for the anion. Remember, we had the same kind of thing down here with the ammonium. The formula was NH4. The little 2 represented the quantity, and that's not information that ALEKS wants us to give. It doesn't want it to tell us, doesn't want us to tell it how many of each ion we have. Now, if you're feeling like you're not going to know whether the 3 should be included or not, if you cannot find it on this list of polyatomic ions, then you should not be including the quantity. The little 3 should be left out completely, right? So that's the case. You're not going to find bromine all by itself on this table of polyatomic ions, which means this 3 does not belong over here. All right, so we can't consult a table of polyatomic ions to help us figure out the charges in this case because we don't have a polyatomic ion. We need to look at the periodic table. We need to find these elements on the periodic table. We have vanadium, which is located right here in an area where we can't predict its charge. And we also have the bromide ion over here. Now, fortunately, the bromide ion is one where we can predict its charge. It's a -1 charge. Thank goodness for that. And we're going to have to figure out the charge on the vanadium. Now, we know that all of these ions are going to add up to a total of 0. We know that we have 3 bromides, and each one of them has a -1 charge, like that. And so this is telling us that our vanadium must have a +3 charge in order for this whole thing to work itself out to being neutral.